For two-dimensional kinematics, we talked about the adding vectors. Let's say if I have two vectors, A and B. If I want to add A to B, I can do it with the tail to tip method. So we can start with A and then put the tail of B at the tip of A. In that case, the A plus B would be this vector right here because we started there, ended there. So this is A plus B. Another method we can use is the parallelogram method. For the parallelogram method, we put the tails of the two vectors together. So we put the A here, B there, the tails now are together. And then we use these two vectors to make a parallelogram. And then the diagonal is the sum. The diagonal also has the tail right there. And that's the diagonal, that's the sum. Not the diagonal that way, not the diagonal going that way, but starts right here, ends right there. If we want to subtract vectors, that means, say, if I want to do A minus B, since we already know how to add vectors, then all we have to do is to do A plus negative B. And that means the vector A plus the opposite direction of the B. This will be the negative B. Then I can add these two vectors using either the tail to tip or the parallelogram method. So in this particular case, it will be A. If I do tail to tip method, I have to put the tail right here. So A minus B would be that vector. That's A minus B because I started there, ended here. And then we study the projectile motion. For projectile motion, we should always separate the horizontal motion and the vertical motion. For horizontal motion, because gravity pulls only straight down in the vertical direction, the horizontal motion is not affected. So the horizontal direction has a constant velocity motion. The vertical side has constant acceleration motion, and that acceleration is the g going downward. So if we choose down as negative, up as positive, then this will be about negative 10 meters per second squared. If it's constant if it's a constant velocity motion, the only equation we use for constant velocity motion is delta x equals to velocity times the time. For constant acceleration motion, we can use any of those four kinematics equations. For projectile motion, we need to make sure we separate the two sides because we have different types of motion. We use different equations, and we also have different values for the acceleration, velocity. The only thing that's the same on both sides is the time. The displacement is also different. Time is the only thing we can use on both sides. We can have a projectile that is shot horizontally. Now this projectile is going to go like this and follow a parabolic path. Again, we should separate the horizontal side and the vertical side. If this is the initial velocity VO, that is the velocity in the horizontal direction. The initial velocity in the vertical direction is 0 because this horizontal velocity does not have any components in the vertical direction. And then, of course, the acceleration on the vertical side is negative 10. So depending on the problem, you just have to list the variables on the appropriate side and use the appropriate equations. Please make sure that you do not mix up the horizontal and the vertical side. And what's the same on the two sides? It's the time. That's the only thing you can use on both sides. We can also have a projectile that is shot at an angle. So let's say speed is VO at an angle theta above the horizontal. This object will go up and then down, and at the maximum height, well, let's see, we'll talk about the maximum height later. Let's see. We separate the horizontal and vertical direction. And because this is a slanted velocity, it has both horizontal and vertical component. So for the horizontal component, we make a parallelogram, and in this case, it will be a rectangle. The side that's horizontal, this is the horizontal component, that is the vertical component. So the horizontal component is adjacent to the angle. That means this is VO times cosine theta. And then the vertical component, of course, is going to be VO times sine theta. And then, of course, acceleration will be the -10. And if you have a problem that doesn't give us the numbers to work with, that means we would keep g as g. That means the acceleration would be -g instead of plugging in the 10 for g. Okay. What is the velocity at the maximum height? At the maximum height, it is a turning point for the vertical direction, because before the maximum height, the object is going up. After the maximum height, the object is going down. So at the maximum height, the y component of the velocity is 0. However, in the x direction, the velocity is not 0 because it's a constant velocity motion in the horizontal direction. This horizontal velocity never changes. So even at the maximum height, we still have this constant x direction horizontal velocity, that's VO cosine theta. So the velocity up there is horizontal VO cosine theta, because the object never turns around in the horizontal direction. The object just keeps going in the horizontal direction at that same constant velocity. We also did these river crossing problems. Let's say we have a river. The river current flows that way at 2 meters per second. And we have a boat. Let's say the boat has a speed of 3 meters per second in still water. Most likely, the two kinds of problems you would see would be for the boat to aim straight across. If the boat aims straight across, that means the boat gives itself a velocity that is 3 meters per second going that way. But the river current also gives the boat a velocity. The river current gives the boat a velocity that is 2 meters per second. So if I put these two velocity vectors tail to tip, I can get the total velocity going that way, which means the boat's total velocity is the sum of these two, because the boat gets two velocities from itself and from the water. Add those together, we get the total velocity of the boat, and that's the velocity of the boat relative to the shore. The 3 meters per second is the velocity of the boat relative to the water. So if you move with the water and look at the boat, you would see the boat only travels that way at 3 meters per second. But if you stand on the shore, that's the velocity of the boat, which means this boat aims straight across is actually going to end up right there. And if we want the boat to end up straight across instead of ending up downstream, that means we need to aim the boat which way? We need to aim the boat a little upstream, like this. So in this case, the boat gives itself a velocity that is 3 meters per second, while the river current gives the boat another velocity that is 2 meters per second. If we aim the boat at just the correct angle, we will end up with a total velocity starting here, ending there. That's the net velocity of the boat. So relative to the shore, the boat will be traveling straight that way. So this boat can end up right there. Let's say the river is 1,000 meters wide. And let's say we need to find the time to cross the river. Okay, we can treat this like a two-dimensional motion. And then we can separate the x direction and the y direction separately. because this 1,000 meters is the delta y, so if I want to find the time to cross the river, I can just use the delta y divided by the velocity in the y direction. So we don't have to look at the slanted distance and the slanted velocity. So the delta y is 1,000. And the velocity's y component is 3. So this will give me the time it takes this boat to get to the other side. And for this one, 3 and 2, if we need to find this y direction velocity, we'll have to use Pythagorean theorem. So this is like a squared equals to c squared minus b squared, because 3 is the hypotenuse. So this one is 3 squared minus 2 squared. So this gives us a square root of 5. So the time for this boat to cross the river, again, would be delta y over the velocity's y component. The delta y is 1,000. The y velocity is square root of 5. For this boat, the entire velocity relative to the shore is the y velocity. And of course, we'll take this boat less time to get to the other side because this boat is using its entire velocity for the y direction to get to the other side. So it has a larger y component velocity than this one. Now you may wish to take a look at the practice problems and find a few problems to do to help with the review. And of course, you can also use Kinematics unit videos for review practice.